Okay, so welcome to this new video series of the unreal numbers. I'm starting this new series where I'll be discussing different topics from different classes from 9 to 12th grade. So today we are starting with the topic of rational and irrational numbers from class 9. In this topic, I'll try to approach the concepts in a different way where I'll be trying to show them visually, which will be a lot more appealing than just learning the concepts, just learning the formulas and like remembering them and everything. Rather than we will focus more on visualization of the concepts. So let's start with rational and irrational numbers. In the starting, I'll be writing a few numbers. You need to tell me whether they are rational or irrational numbers. You don't know about rational numbers, irrational numbers, anything right now. Okay, so but still try to guess. Let's say I'm writing root over 7 by 2. Let's say I'm writing one more number that is 1 by 2. Maybe I'm writing, let's say, 3 by 0 and maybe 0 by 4. I've written four numbers here. What do you think? Which of them are rational numbers and which are not? Okay. So if you just look at most of you might say that a number which is of the form P by Q is a rational number. Yes, that's correct. But there are something missing here. What is missing? If we just look at the first number, it is already of the form of P by Q. Actually, all of them are in the form of P by Q. So are all of them rational numbers? No. Here, since this root 7 does not qualify to does not permit the number to be a rational number. So that is why this is not a rational number. Okay. Though it is of the form P by Q, still it is not a rational number. This one is a rational number. This one is again not a rational number. Okay. This one is again a rational number. So why these two numbers are different? Why they do not qualify to be a rational number? So that is why we should, whenever we are doing the definition, we should write it like this. Any number of the form P by Q such that Q must not be equal to 0. Because if Q is equal to 0, the number itself becomes undefined. We know anything divided by 0 becomes undefined. Okay. Then P and Q both should be integers. That is the most important thing. If P and Q are not integers, it may not be a rational number. Okay. For example, if you look at this number, root 7, it is not an integer. What are integers? The numbers like plus 1, 2, 3, 4, minus 1, minus 2, minus 3, 4, and so on. 0 is also an integer. So root 7 is not one of them. And that is why, though it is of the form P by Q, it does not qualify to be a rational number. We will later prove that root 7 is not a rational number. In this series only, we'll later prove that. Okay. So after that, one more thing is very interesting. We need to add it here. For example, if I write two numbers, let's say I write 3 by 6 and uh, let's say 9 by 18. Are these numbers, this number over here, 1 by 2, 3 by 6 and 9 by 18, are they rational number? Do they qualify? Do they satisfy all of these conditions? Yes, they are in the form of P by Q. Q is not equal to 0. None of them have denominator equal to 0. And both the numerator and denominator are integers. So they are indeed rational numbers. But the question is, are they unique numbers? They are not, because we all know how to simplify fractions. 3 and 6 can be simplified and we can get 1 by 2 by cancelling it. Similarly, 9 by 18 can be simplified and we get 1 by 2. So to express the rational numbers uniquely, we use another part in this definition, that is P and Q are co-prime. What does this co-prime means? The word co-prime means two numbers such that they do not have anything common, any factor common other than 1. Example, let's say 9 and 16. If you look at these two numbers, they are not, they do not share any common factor other than 1. So they are two co-prime numbers. Can you give other example of co-prime numbers? You can write in the comment box. Okay. So this is the complete definition of rational number. A number which is of the form p by q. Q must not be equal to 0. That is, denominator must not be equal to 0. P and Q both are integers and PQ are co-prime numbers. Okay. Now let's look at the next segment of our video, that is position of the numbers, rational numbers on the number line. Okay. So that is a geometrical view of numbers. We all know that we have learned about number line in our childhood. There is a line which contains number like 0, which is somewhere in the middle. Then on the right side of 0, it contains, in regular gap, it contains the positive integers, that is 1, 2, 3, 4, and so on. Similarly, on the left hand side of 0, they contains the negative numbers like 1, -1, -2, -3, -4, and so on. But where are the positions of these rational numbers? Or may I say the fractions? Okay. So to understand this, I'll be writing a few fractions over here. Let's say maybe 7 by 3 or 5 by 3 or 4 by 3, maybe 2 by 3, 1 by 3. What are the positions of these rational numbers? To understand that, we need to first understand how fraction works. What is a fraction? Fraction represents, see, whenever you see something as a whole, that is, and that is a natural number, that is a positive integer. For example, I see this pen, this is a whole pen, right? Every part of that pen is here, present here, right? So that pen is basically one pen. If I had two of this, I would say two pen, three pen, and so on. So what I'm doing, I'm counting the pen in natural numbers, correct? Okay. So if I now break this pen, if I now just break it into parts, both the parts will be a portion of that. So that is a fraction of that pen. Let us try to understand by another example. Let's say you have a cake. Let's say you have this cake and it's your birthday party. So you have invited your friends, maybe three friends you have invited. So you want to cut the cake and distribute the cake among them, right? So this cake was one. It was a whole cake, so it was one. Now you have cut it in three equal pieces. You have cut the cake in three equal pieces. This is piece number 1, this is number 2, and this is number 3. So you give it to your first friend. You give this piece to your first friend. So what portion of the friend, what portion of the cake your friend got, first friend? It was 3 equal parts of that cake, out of which your friend got 1. So your friend actually received 1/3 of that cake. Similarly, let's say you gave both of this second and third piece to your another friend, received by the second friend. So your second friend got 2 piece out of 3 piece. That means that is 2/3 of the cake received by your friend. So that is basically the concept of fraction. When you break a whole number into certain number of pieces, each piece denotes the numerator, and how many pieces of the whole number you made, that denotes the denominator. Let me repeat again. Denominator repeats. Denominator represents that how many pieces of whole number. Whole number. And numerator represents how many pieces are taken. Okay. So let's say now if I want to represent all of these fractions, we may see that the fractions have a similar denominator. Okay. So here the whole number is being divided into three equal parts, each of the whole number. So what is a whole number here? See, 0 to 1 is a whole number. 1 to 2, this gap represents a whole number. 2 to 3, that gap represents a whole number. 3 to 4 represent another whole number, and so on. So if I divide that whole number, first whole number, into three equal pieces, this is number one piece, second piece, and third piece. Similarly, I divide the next whole number into three equal pieces, again in three equal pieces, and so on. Similarly, if I divide this number also in three equal pieces, this number also in three equal pieces, and so on. Okay. So starting from zero, and we also know that whenever numbers are positive, they always lie on the right side of zero. And if they are negative, lies on the left side of zero. So if I just select one piece starting from zero, that will be one piece out of three pieces. That number must represent 1/3. Out of three pieces of a whole number, we have selected only one. Now, similarly, the next piece would represent 2/3. Next piece is representing 3 out of 3, which is actually 1, and that we can also see. So it represents a whole. But what about the next one? This represent, we have taken a whole and one more piece out of the three pieces. So it is a whole and 1/3, a whole and 1/3. And that in improper fraction transforms into 4 out of 3, because we have taken four pieces where the denominator is 3. That means each whole number is broken into three pieces. I hope the concept is clear. Similarly, for negative numbers, let's see if I have something like this -7/3. If I want to represent that number on the number line, I would be going this side, left side of 0, and I'll be taking 7 pieces where each whole number are broken into 3 equal pieces. So I'll be taking 1, 2, 3, 4, 5, 6, 7. And I would appear here, and that should be -7/3. So this is how any fraction, any rational number can be represented on the number line. So in the first video, that will be we will wrap up here. That will be all for this video. In the next video, I'm going to come up with the concept of density property of the number line. So thank you for watching. Please subscribe and be connected to our channel and support our channel if you want a simple, logical, and visual approach of mathematical problems like this one. Thank you for watching.